Hi, I'm Jomarielle and I'm here to discuss to you about Bernoulli's equation. So look at my work. It kind of looks like a work of an elementary student and not an engineering student. It's because I'm using an iPad mini and it's kind of hard to write stuffs here, but I'm trying my best to make my work understandable as possible. So I am so sorry. So here, going back to Bernoulli's equation, in this section, we're going to take a look at the differential equation in the form of dy over dx plus p function of x y is equals to cube function of x y raised to n. So we're dealing with the first order Bernoulli's equation. We'll come across some time that quite looks much like a linear form. Here, I'm going to box the linear form. This is the linear form. The dy over dx plus p function of x y is equals to q function of x. But with the Bernoulli's equation has an extra term here, y raised to n. Yeah, that's really y raised to n. I'm so sorry. The extension of some linear form and we multiply it to y with some power here, the y raised to n, where n should not be equal to 1, thus it will be a linear equation. So here I'm going to show you some examples of Bernoulli's equation. So the Bernoulli's equation is dy over dx plus p function of x times y is equals to q function of x times y raised to n. Here is my first example. dy over dx minus y over x is equals to x times y squared. That's very simple. The p of x here, the p function of x here is 1 over x. And the q function of x here is x. And the variable n is 2 because y is raised to 2, y squared. So n is equals to 2. Second example. Okay, another example. This is a more complex example than that of the first example. Here, I'm going to show you dy over dx plus 2xy plus x y raised to 4 is equals to 0. We're going to transpose x. We're going to transpose the xy raised to 4 and we're going to get dy over dx plus 2xy is equals to negative x times y raised to 4. So our p of x here is 2x. The q of x here is negative x. And n is equals to 4. Another example, what if we reverse the dy over dx to dx over dy? That means that the y and x should be reversed too. Here, I'm going to make an equation that's reversed. So, dx over dy plus xy is equals to x cubed times y. So here, if we reverse it, if we reverse the dy over dx to dx over dy, the Bernoulli's equation will become dx over dy plus p function of y times x is equals to q function of y x raised to n. I'm going to write it. I'm going to show you. Okay. Dx over dy plus p function of y x equals to q function of x rather y times x raised to n. Oh, that is n here. Okay, that's n. I'm just having a hard time writing at the iPad. So this is the reversed one. We're going to answer my example. This is my reverse example, dx over dy plus xy is equals to x cubed y. The p function of y here is simply y. The q function of y here is y also, and the n is equal to 3 because x has a variable 3. It is raised to 3. So, there. So, how are we going to solve the Bernoulli's equation? We can solve the Bernoulli's equation by making it become a linear equation. How to make Bernoulli's equation become a linear equation? Well, you must multiply it to a certain variable to make it a linear equation. And this is the variable. I'm going to write it. There. 1 minus n times y raised to negative n. That's the variable you can multiply to the Bernoulli's equation to make it into a linear equation. So, let's go try it to my first example, my simplest example. Dy over dx minus y over x is equals to x y squared. So, the p function of x here is 1 over x, and the q function of x here is x. And the n here is equals to 2. So, we're going to try the 1 minus n times y raised to negative n. 1 minus 2 is negative 1. So, negative y raised to negative 2. There. We're going to multiply the negative y raised to negative 2 to dy over dx minus y over x is equals to x y squared. We're going to multiply this negative y raised to negative 2 to this equation to make it into a linear equation. So, let's try if it really will become a linear equation. So there. As you can see this, I'm going to box it for you to see it clearer. There, I got a linear equation. A linear equation of negative y raised to negative 2 dy over dx minus 1 over xy is equals to negative x, where the p of function of x is negative 1 over x, and the q function of x is negative x.